Our next step is the mantle. Okay, so the mantle actually makes up 82% of the Earth's volume and 65% of the Earth's mass. In other words, most of the Earth is actually the mantle. Okay, the mantle is, again, the thickest layer. You could probably figure that out based on its 82% of the volume and 65% of the mass. Okay, it is about 2,900 kilometers from top to bottom. Okay, the mantle is rich in silicon and oxygen. It also does contain other heavier elements such as iron, magnesium, and calcium. Now we split up the mantle into two regions, the upper mantle and the lower mantle. The lower mantle extends from around 700 kilometers all the way down to the outer core. So it's about 2,200 kilometers thick. The lower mantle is under intense pressure, so it's actually a solid. Similar to why the inner core is a solid, the lower mantle is also a solid. The upper mantle is actually split into two different zones. The lower section is the asthenosphere. So within the asthenosphere, it is hot enough and has a low enough pressure that it is still solid, but it is a plastic solid. What we mean by a plastic solid is that it is moldable, it's malleable. It will actually flow under pressure. So for example, think about something like clay or Play-Doh. If you just leave it alone, it's a solid, but if you press on it, then it will move and bend and flow. So that is a plastic solid. So the asthenosphere is actually a plastic solid. So it can actually flow under pressure, and the motion of the asthenosphere can actually have effects on the crust. We'll talk about more about that when we talk about plate tectonics. The upper region of the upper mantle, so the upper part, is the lithosphere. The lithosphere is the region that is cool and rigid. So this is not a plastic solid. This is a rigid solid. Normally what you think about a rock. It's not going to bend or flow. So it does not flow, but it rides on top of the asthenosphere. And because it is rigid, it actually is broken into individual plates. So the lithosphere is the upper part of the mantle as well as the crust. Now the movement of the lithospheric plates leads to earthquakes, volcanic activity, and deformation of rock. We'll talk more about all of that when we get to plate tectonics. Now the Earth's crust has two different regions. So all of this is the outer layer, but we see kind of two different types. There is the oceanic crust, which is primarily made of relatively dense basalt. It is denser than the continental crust. It's not as dense as the mantle. So it's made of dense basaltic rocks and has an average thickness of about 10 kilometers. The other region is the continental crust, which is made of granite or granitic rocks, which is less dense, and it will vary in thickness from about 20 to 60 kilometers. So to help us understand what's going on with these different layers, we have the idea of isostasy. So iso means equal, and stasy means standing. So this is equal standing. Isostasy actually comes from, why this happens, is because of buoyancy versus gravity. So we have gravity trying to pull everything down to the center of the Earth, but then because the crust is less dense, we have buoyancy pushing it back up. So isostasy occurs where we get the balance between gravity pulling down and buoyancy pushing up. So the lower density crust is floating on top of the higher density mantle. So the reason why continents rise higher up than the oceans is because of isostasy. The continental crust is thicker, which means it is displacing more of the mantle. So we get a greater push up. It is also less dense, and so we get a higher push up. So crust, the continental crust, is thicker and therefore rises higher above the more dense but thinner oceanic crust. Here is our third lecture quiz question. The Earth's crust is thicker beneath a mountain because A, The roots of the mountain are heavier than the mountain at the surface. B. Mountains sink until the upward buoyant force balances the downward gravitational force. C. Mantle rock is weak beneath the mountain. Or D. Oceanic crust is thin. Go ahead and think about it for a second, and then we'll discuss. All right, so the answer is B. It's all about isostasy, and isostasy is going to be this balance between the buoyant force pushing up and gravity pulling down. Okay, so it's all about B. The mountain ranges are a region of thicker crust, and because it is thicker, it's going to displace more and have a greater buoyant force, so it's going to rise higher as well. Okay, it's both deeper and higher because it is thicker.